Hello guys, this is Camplified and today we will talk about laws of chemical combinations. The combination of elements to form compounds is governed by 5 basic laws of chemical combinations. Let's see the first one, that is law of conservation of mass. It simply states that matter can neither be created nor be destroyed. In terms of chemistry, you can write in a chemical reaction, mass is neither created nor destroyed. Let's take a simple example. CH4 plus 2O2 gives CO2 plus 2H2O. Now, in this reaction, only one molecule is not reacting, right? There are lot of CH4, lot of O2, which are giving carbon dioxide and water. But we are considering only one molecule which is reacting, that is one molecule of CH4 and one molecule of oxygen, right? Here two molecules are combining for CH4. Now atomic mass for CH4 is 16. Atomic mass for 2O2 will be 64. How many oxygen atoms are there? There are 4 oxygen atoms. For the 4 oxygen atom, the atomic mass will be 64. Now atomic mass of CO2 will be 44. Last, atomic mass of water will be 36. Now we can say that 16 gram of CH4 will react with 64 gram of 2O2 to give 44 gram of carbon dioxide and 36 gram of water. Now if you look closely, the total mass of reactant and product is 80 gram. So on both the sides, reactants and products have equal mass. This is law of conservation of mass. Let's move to the second. Given compound always contains exactly same proportion of elements by weight. What is the meaning of this statement? Let's take a simple example of water, that is H2O. You can take the water sample from any source, example rainwater, ocean, ground, etc. And after analyzing, you will always find that hydrogen is combining with oxygen in a fixed ratio or in fixed weight to give H2O. You will find that 1 gram, not 1 gram, 2 gram of hydrogen is combining with 16 gram of oxygen, and this ratio will never change. In place of 2 gram or 16 gram, if you take 2 gram of hydrogen and 16, in place of 16 gram you are taking 32 gram, then also the hydrogen will only react with 16 gram of oxygen, right? And the remaining 16 gram will be left out as it is. So this proportion will never change. 2 gram of hydrogen will always react with 16 gram oxygen only. Even if you put the amount other than 16 gram, the oxygen will not react further. Now let's take some other examples. CO2, this will also react in this proportion. NH3, the proportion of weight will always remain the same. 14 gram of nitrogen will react with 3 gram of hydrogen. This is law of definite proportions. Let's move to the next law. Third one is law of multiple proportions. The statement is, if two elements can combine to form more than one compound, the masses of one element that combines with the fixed mass of other element are in ratio of small whole numbers. Now what is the meaning of this statement? To understand the meaning, let's take example. Hydrogen plus oxygen will give water. Another example, hydrogen plus oxygen will give hydrogen peroxide. Right? Hydrogen and oxygen will give two different compounds, water and hydrogen peroxide. Now look at the statement. If two elements can combine to form more than one compound, our two elements are hydrogen and oxygen. They both are combining to form two more than one compound, that is water and hydrogen peroxide. Now, the masses of one element that combines with the fixed mass. Let's give the mass. 2 gram hydrogen will react with 16 gram oxygen to give 18 gram water. And next one, 2 gram hydrogen will react with 32 gram of oxygen to give 34 gram of hydrogen peroxide, H2O2 and H2O. Now let's see again, masses of one element that combines with the fixed mass of other element. The fixed mass is hydrogen, 2 gram, 2 gram. The other mass is of oxygen, that is 16 gram and 32 gram. So we are talking about the ratio of oxygen or of the element whose mass is not fixed. So in this place, the mass of oxygen is not fixed. So we are talking about the ratio of oxygen, that is 16:32 or 1:2. This is the ratio, and this ratio is of small whole numbers. Let's move to the next. The fourth one is Gay-Lussac's law of gaseous volumes. It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume. Unit kuch bhi ho, you can use any unit. The ratio is by volume and the unit can be later centimeter cube, meter cube, like that. Provided, now this is the condition, provided all gases are at same temperature and pressure. What are the condition? The temperature and pressure should be same. Now what is it trying to say? Let us consider a simple example of hydrogen and oxygen. Hydrogen will react with oxygen to give water, right? Now all this is in gaseous state. We are talking about volume, so either you have to take it in gaseous state or liquid state. It doesn't matter, right? So we will take general form, hydrogen plus oxygen will give you water. Now when we write it in the equation form, H2 plus O2 gives H2O, but this is not the correct equation, right? The correct equation will be 2H2 plus O2 will give 2H2O. This is the correct equation of formation of water using hydrogen and oxygen. Now if you look closely, I can write two volumes of H2 react with one volume of O2 to give two volumes of H2O. By volume, I can take liter, meter cube or centimeter cube units, I am taking general form, so I am writing volume instead of units. So 2 volumes of hydrogen will react with 1 volume of oxygen to give 2 volumes of H2O. This is in the ratio 2:1:2. This is the ratio we are talking about. Now how did this happen? How can there will be 2 volume of hydrogen reacting with oxygen to give 2 volumes of water? Now you should be thinking that 2 plus 1, this 2 plus 1 O2 must give 3, right? But this is not the way. For this we have to take a look at Avogadro's law, which states that at a particular temperature and pressure, equal volume of gases will have equal number of molecules or particles. Avogadro's law is the next basic law which we are going to talk about. So before that you should consider this much only. We will talk about Avogadro's law in the next or 5th part. So for Gay-Lussac law of gaseous volumes, the ratio which we are talking about is the ratio of volumes of different gases involved in the reaction, that is hydrogen, oxygen and water vapor. Now let's go for the 5th law of gases, chemical combinations. 5th one is Avogadro law. It states that equal volume of gases at same temperature and pressure should contain equal number of molecules. Now this one is related to the previous one, Gay-Lussac law. Let's see it in a little bit more elaborated way. In the previous part, 4th part, we saw hydrogen plus oxygen. How they were combining, let's see. Let's consider some molecules of hydrogen, right? Now there are 2 volumes of hydrogen that were combining. So we are taking 2 volumes of hydrogen. These are the 2 volumes of hydrogen, right? Reacting with 1 volume of oxygen. All right. Making, this is 1 volume of oxygen, making 2 volume of water. Now the molecules will be like this. Now let's count. How many hydrogen molecules are there? 5 in this one, 5 in this one, completely making it 10H2, right? Now how many oxygen are there? 1, 2, 3, 4 and 5, making it 5O2, giving how many water molecules? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10H2O. Now when you look at the ratio will be 10. Let's consider the ratio along the side. 10:5:10. This will be the ratio. Dividing the whole by 5, you will get 2:1:2. Do you remember this ratio? This one is the ratio that you found in the previous one, that is the 4th one. 2:1:2. So these two are connected. We have seen in two different ways, but the ratio will always remain the same. That is 2:1:2. This is Avogadro's law. The number of molecules remains equal under same conditions of temperature and pressure. Right? So this is the fifth and the last basic law of chemical combinations. This will be it for today's video. Thank you very much.